Section 2.1, Writing Code the F-sharp Way. Let's start by considering some of the principles behind F-sharp with a quick compare and contrast with typical so-called curly brace languages such as Java and C-sharp. It's worth doing before we start diving into the code so that you're mentally prepared for some of the differences you might observe when doing F-sharp. In some ways, much of what you read in this section is similar to what I said in Chapter 1, except this is a more code-focused examination. How much of a functional programming language is F-sharp? We'll cover this in more detail later, but in a nutshell, F-sharp encourages what I consider the two most important parts of functional programming, FP, expressions, and immutability. It also has many other features that support flexible functions, such as composition and currying, and numerous recently added features have made their way into many other languages, such as lambdas and pattern matching. However, it doesn't support or enforce more hardcore FP features, such as pure functions, type classes, or higher-kinded types. Section 2.1.1, What, Not How. Imperative code can be thought of as the low-level how you want to implement something, typically a set of lower-level instructions. Conversely, declarative code concentrates more on expressing the what you want to achieve, and leaving the low-level details to another party. In this case, a compiler. Here's an example of an imperative way of filtering out odd numbers from a list using both imperative code, I'm using C-sharp syntax here, and the equivalent declarative variant, written in F-sharp.
See this code.
Both samples do the same thing. However, while the declarative version is focused on stating what we want and leaving the compiler to work out the nitty-gritty, the imperative version takes ownership of how we want to filter the numbers by creating an intermediary list, iterating through each item one by one, etc. Of course, most languages have libraries to support a declarative model, such as LINQ in C-sharp, streams in Java, and so on. In F-sharp, this is the de facto way of working and is much more pervasive than you might be used to. If you're used to the imperative model of developing, this can feel a little like giving up control. However, once you're used to it, it's very difficult to go back. Section 2.1.2, Composability. F-sharp also emphasizes composition rather than inheritance to achieve reuse, with support for this baked into the language. Functions are the main component of reuse rather than classes, so expect to write small functions that plug together to create powerful abstractions. Individual functions are nearly always easier to understand and reason about.
All right, hold on. Why isn't that off rip, brother? First example doesn't even work. So on the left here is link pad, by the way. It's really neat. It seems like it's, well, let me just show you. It's like SSMS for C-sharp and F-sharp. It's like a beefier version. But you can also write SQL in it. It looks pretty sick. I went ahead and bought there's a free version of it, but I bought the paid version. Not that bad, $125 for lifetime updates, so that's what I'm gonna be using. But yeah, it gave me like SQL notebook vibes, which is pretty cool. I love being able to write code like this. Kind of like the what was the name of that program? Not the Python notebooks, Observable for JavaScript. Yeah, anyway, if you're wondering, that's what this is. So, okay, so now why isn't this working? Thought it was low level. How you want to implement something typically. Oh, because it's C-sharp. Okay, there you go. Makes sense, F-sharp book, but you give me C-sharp. Thanks, dude.
Of course, most languages have libraries to support a declarative model, such as LINQ in C-sharp, streams in Java, and so on. In F-sharp, This is the de facto way of working and is much more pervasive than you might be used to. If you're used to the imperative model of developing, this can feel a little like giving up control. However, once you're used to it, it's very difficult to go back. Section 2.1.2, Composability. F# also emphasizes composition rather than inheritance to achieve reuse, with support for this baked into the language. Functions are the main component of reuse rather than classes, so expect to write small functions that plug together to create powerful abstractions. Individual functions are nearly always easier to understand and reason about than entire sets of methods coupled together through state in a class. As such, making changes to existing code is much easier to do with a greater degree of confidence. Here's a simple example of how we might build behaviors into more powerful ones in C# and F#, trying to get all even numbers from a list and then square each. Again, in C#, I've deliberately kept things at the method level, but you should also consider the effort required when trying to compose more complex sorts of behaviors across classes and objects.
See this code.
Where are the types? F# is a statically typed language, just like languages such as Java and C#. But it has an extremely powerful type inference engine, which means it has the succinctness close to dynamic languages such as Python, yet with the backing of a strong type system and compiler, so you get the best of both worlds. More on this later. I'm not going to explain what the forward composition symbol does yet, but if you look at the F# version of code, imperative code can be thought of as the low-level how you want to implement something, typically a set of lower-level instructions. Conversely, declarative code concentrates more on expressing the what you want to achieve, and leaving the low-level details to another party. In this case, a compiler. Here's an example of an imperative way of filtering out odd numbers from a list using both imperative code, I'm using C# syntax here, and the equivalent declarative variant, written in F#.
See this code.
Oh, my bad. Okay, I see. So that's F#. Let's see. Filtering out odd numbers from a list. i.e. numerable, generic, integer, function, get even numbers, argument, generic. What is this? I thought the type was ahead of C, or ahead of the variables. Oh, well, it doesn't matter. This is the F# though. Okay, so let me try even numbers, even more, seek, sec, filter, fun for lambda. Oh my god. Return number. Modulus. So mod 2 would be equal 0 because divided by itself should always be 0 if it's an even number. I'm choking on flower seed. Okay. Unexpected. Incomplete. What? Oh, my bad. Okay. I take it this is not a fully working example, just a code example.
See
Oh
this
my gosh.
code.
We'll move on.
Both samples
There'll be
do the
plenty of
same
code
thing.
later.
However, while the declarative version is focused on stating what we want and leaving the compiler to work out the nitty-gritty, the imperative version takes ownership of how we want to filter the numbers by creating an intermediary list, iterating through each item one by one, etc. Of course, most languages have libraries to support a declarative model, such as LINQ in C#, streams in Java, and so on. In F#, this is the de facto way of working and is much more pervasive than you might be used to. If you're used to the imperative model of developing, this can feel a little like giving up control. However, once you're used to it, it's very difficult to go back. Section 2.1.2, Composability. F# also emphasizes composition rather than inheritance to achieve reuse, with support for this baked into the language. Functions are the main component of reuse rather than classes, so expect to write small functions that plug together to create powerful abstractions. Individual functions are nearly always easier to understand and reason about than entire sets of methods coupled together through state in a class. As such, making changes to existing code is much easier to do with a greater degree of confidence. Here's a simple example of how we might build behaviors into more powerful ones in C# and F#, trying to get all even numbers from a list and then square each. Again, in C#, I've deliberately kept things at the method level, but you should also consider the effort required when trying to compose more complex sorts of behaviors across classes and objects.
See this code.
Where are the types? F# is a statically typed language, just like languages such as Java and C#. But it has an extremely powerful type inference engine, which means it has the succinctness close to dynamic languages such as Python, yet with the backing of a strong type system and compiler, so you get the best of both worlds. More on this later. I'm not going to explain what the forward composition symbol does yet, but if you look at the F# version of code, you can visually observe that we're somehow plugging the getEven numbers and square numbers functions together. This mode of design is, again, very common, building small functions and bits of code that do a single thing well, and then composing them together into larger, more complex parts later. Section 2.1.3, Data and Behavior. Another key pattern you'll commonly see in F# is a clear separation of data and behavior. If you're coming from a language that uses object orientation, OO, as the key mechanism for organizing code, you'll find this a little different. Instead of having classes that have both state and behaviors fused together, F# encourages you to design code with simple data types with modules of functions that act on those types. For example, in the OO world, in a retail web application, you might have a basket class with methods such as addItem, clear, and checkout on them, plus the internal encapsulated state, what the items in the basket are, etc. When you call methods on them, they would perform some action and modify that internal private state. In the FP world, you'd have an immutable record that stores the current state of the basket, for example, what the items in it are, and a module with stateless functions such as addItem, clear, and checkout. Each function would do some action and then return an updated version of the basket. This generally leads to much simpler code that's easier to write, understand, and test, and is more flexible and simpler to maintain. Of course, you'll learn exactly why that is in this book. Section 2.1.4, Working with a Smarter Compiler. F# as a language inevitably changes how you write code. I think of myself as a lazy developer. I like having things done for me. F# helps a great deal in this regard, especially for boilerplate activities that in other languages. Section 2.2, F# and .NET. .NET is the runtime or platform that F# code primarily executes on, although that's not the only platform that F# can target. .NET is free to use, open source, cross-platform, and capable of running on Windows, Mac, and Linux. Although the majority of .NET is written in and primarily designed for consumption by C#, F# has great support for interacting with C# code. .NET provides a great deal of functionality and capabilities that you can directly use from F#, whether it's working with the file system, automated memory management, web development, or databases. In addition, you can download over 200,000 ready-made packages from the official NuGet website. So, if you're already a .NET developer, you're not going to have to give up the libraries that you already know, or the knowledge you've learned over the past years regarding the Common Language Runtime, CLR, garbage collection, reflection, and so forth. And if you're not a C# expert, the documentation you read about .NET, even if the samples are written C#, will generally be just as applicable to F#. Figure 2.1 shows how the three main languages, C#, F#, and VB.NET, running on .NET today, can work together in a single application. All three compile into the same interoperable intermediary language, IL, and exist on top of the same CLR. Section 2.3, Creating your first F# program. There's one thing I've learned from teaching F# for some years now, and that's that you won't learn it unless you do it. So let's start as we mean to go on and write some basic F# together. Section 2.3.1, Installing F#. As an integral part of .NET, F# can be Historically, .NET was very much a thing that was highly coupled to Microsoft's own IDE, Visual Studio. Today, things are very different. .NET can be installed without any IDE and has a rich and extensible command line tooling platform known as the .NET CLI. The CLI lets us perform many actions that historically would only have been possible through Visual Studio, such as creating, building, running, and testing your applications. Wherever possible, we'll be using the .NET CLI that is included with .NET 6 for all such activities. There are many benefits to this approach. For example, it works consistently across all operating systems, which makes my life as an author much easier, and can be much more easily automated than using a GUI. However, if you prefer a point-and-click approach, the main IDEs all support the ability to create applications via menus and wizards. Section 2.3.3, Hello World in F#. Let's create a basic F# console application using the .NET CLI. Start by opening a terminal window and enter the following commands.
See this code.
Can I create other application types? The .NET New command can create a whole host of different application types, for example, web apps, class libraries, etc., called templates. You can see all the available templates using the .NET New -- list command. What's especially good is that the templates stored in .NET are extensible, so you can build your own and share them on .NET's NuGet package management system. The very first time you run this, you'll get a bunch of text, but at the end, you should see something like the following.
See this code.
If you now get a directory listing using, for example, the dir or ls commands, you'll see that two files have been created.
See this code.
Why do I need to specify F#? Don't forget that .NET supports three languages, C#, F#, and Visual Basic, VB.NET. C# is the default language for the .NET CLI, so you need to specify lang F# whenever you want to create a new template that supports both F# and C#. However, you can switch F# to be the default language instead by setting the .NET_new_preferred_lang environment variable to the value F#. Doing this means you won't have to enter -lang ever again. We'll investigate the contents of those files in a short while, but for now, let's just run the application using the command .NET run. We'll investigate the contents of those files in a short while, but for now, let's just run the application using the command .NET run. After a short delay, you should see the following output.
See this code.
Congratulations, you've now created and run your very first F# application. Section 2.4, Getting Started with Visual Studio Code. It's time to look at some F# for the first time. While you could use a simple text editor to do this, F# applications are just text files. Let's take this opportunity to install a free dedicated code editor called Visual Studio Code, or VS Code. VS Code is an extensible, mostly, open-source free code editor that works across the three main OS choices: Linux, Mac, and Windows. VS Code can be downloaded and installed from code.visualstudio.com. Follow the appropriate installation guide for your operating system. What IDEs can I use with F#? There are three main options for F# IDE that I would recommend today. Microsoft Visual Studio, which is Windows only, and has a free Community Edition and paid licenses, as well as a sibling for Apple, VS for Mac. Second, JetBrains Rider is a commercial IDE that works across all three OSs. Lastly, there's VS Code. Section 2.4.1, the Ionide extension. Out of the box, VS Code doesn't support F#. That's not a surprise or a problem because VS Code is designed to be an extensible and language-agnostic code editor. To add F# support, you need to install the Ionide extension. This free extension provides rich F# support, including code completion, type hinting, navigation, and refactorings. 1. Navigate to the Extensions panel. View menu Extensions. 2. In the search box, search for Ionide. 3. Find the Ionide F# extension and click the Install button.
I'm not going to do that.
After a short delay, the extension will install. You're now good to go.
So I can look at this girl.
Section 2.4.2, Exploring F# with
No,
VS
not really.
Code.
Just work pays for it, so.
Let's start by loading the Hello World application that you created earlier into VS Code. One way to do that is by navigating within a terminal into the Hello World directory you created earlier and entering the command.
See this code.
Note the period at the end, which tells VS Code to open in the current directory. You'll now be looking at a window something like Figure 2.2.
Figure 2.2.
Pretty simple, right? No need for classes or static void main or opening namespaces or importing modules, just some simple code. The first line is a comment that starts with /. The second line is actual F#. Printfn is a function that prints some text to the console. It actually does more than that, but for now, that's sufficient. There's also an .fsproj file, which isn't necessary to look at just yet. It contains the manifest of your application, such as what type of project it is. For example, there's also an .fsproj file, which isn't necessary to look at just yet. It contains the manifest of your application, such as what type of project it is, for example, an executable or reusable library, and the explicit list of all the F# files to compile. This is unlike some platforms where all files in the folder are automatically used. Section 2.4.3, Writing your first F#. Let's make a quick change to the application so that it prints your name and the current date and time.
See this code.
The first line assigns
Did it work? Loaded, skip, no error, program has exited with code 0. Where's my output? Oh, it's up here. Hello, my name is Wicca Wicca. 215, okay. Alright.
The first line assigns the value Isaac to the symbol name. Note that I didn't use the word variable, but symbol. There's a good reason for that, which will become clear later. The second line gets the current date and time in UTC format using the date-time type, which lives in the system namespace. What's a namespace? The first line assigns the value Isaac to the symbol name. Note that I didn't use the word variable, but symbol. There's a good reason for that, which will become clear later. The second line gets the current date and time in UTC format using the date-time type, which lives in the system namespace. What's a namespace? A namespace is a way to logically group types in a system. Many of the core types in .NET live in the system namespace, including primitive types such as string and int32, and common classes such as environment, among others. We'll come back to namespaces later. The third and final line has also changed in several ways from our original application. We've prepended the $sign symbol at the start of the string, which allows us to inject any value directly within the string as long as it's surrounded by curly brackets. This is known as string interpolation. We've used this to inject name and time into the string. Launch the program again using .NET Run and observe that the output is changed as expected.
See this code.
Congratulations! You've now actually written your first F# code. You should now take the time to configure VS Code to your liking. As VS Code is always changing with new features and extensions, you should also take some time to see what else is out there that suits the way you like to work. Section 2.5, REPL and Scripts. You've now seen how to work with console applications, a concept that I expect is familiar to you regardless of which language you're coming from. However, there's another side to developing F#, which you may or may not be familiar with: scripting. You might already be familiar with some languages that have good support for scripting, including Python and Clojure. Others, such as Java and C#, have more limited or even non-existent scripting modes. Section 2.5.1, the F# REPL. A core part of scripting is having a great REPL. REPL, which stands for Read Evaluate Print Loop, is a mechanism that allows you to enter arbitrary, ad hoc code into a standalone environment and get immediate feedback without compiling and building a dedicated application. Instead of being used when running an application, a REPL is used when developing it. FSI is an application that is bundled with .NET. To run it, open a terminal and type .NET FSI. You'll see a response that looks something like the following.
See this code.
The prompt at the end is where you can start typing in F#. Let's test it out. If you've tried the preceding exercise, your first thought was probably something like, well, this is quite useful, but it's all in a basic command prompt. You get no syntax highlighting, no IntelliSense support, no nothing really. Working directly in FSI isn't great fun. Luckily, there's a much better way to work with FSI that does give you IntelliSense and syntax highlighting: F# scripts. Scripts are standalone F# files that have the extension .fsx. They don't require a project file and can be executed either as a single file of sequential commands or in an interactive mode where you can write code in a file with full editor support but send F# code line by line to the FSI and observe the results. Let's try it out. 1. In VS Code, create and open a new file called scratchpad.fsx. 2. To finish this chapter, let's create and test a function in our script that takes in someone's name and age and returns a string that's a greeting of the person. After all, F# is a functional language, right? Enter the following code in the script file that you already have open or create a new one. It doesn't matter.
See this code.
Whether you use a tab or spaces, make sure that the body of the function is indented at least one space from the definition. Most people use 4 spaces. Now, execute the function into FSI again using the send to FSI command. You'll notice no result is displayed. All we've done is compile the function into FSI.
See this code.
The '(A) and '(B) represent generic types. We'll cover this later in more depth, but this is saying that name and age can be any type string, integer, or customer. It doesn't matter at this point. The function will work with anything. Back in the script, call the function, which will correctly generate the correct string as an output.
See this code.
You can now change the values of the parameters to the function and prove that it correctly executes each time. Section 2.6, Development Flows. Now that you've had a quick play with scripts, I want to compare them to other development flows that we commonly use today, so that you can gain an understanding of where they are best utilized. Scripts are a great way to use F# in an interactive and lightweight fashion, and much of what we do in this book will focus on them. For many F# developers, including myself, scripts form an integral part of the development life. Now that you've had a quick play with scripts, I want to compare them to other development flows that we commonly use today, so that you can gain an understanding of where they are best utilized. Scripts are a great way to use F# in an interactive and lightweight fashion, and much of what we do in this book will focus on them. For many F# developers, including myself, scripts form an integral part of the development lifecycle, particularly in the exploratory phase of development, when you're trying out different ways of representing data, experimenting with third-party packages, etc., and I would highly encourage you to use it. They can enhance or replace several other development flows. Application-oriented development. When you develop your application and prove to yourself it works by running it and navigating to that section of the app to stress the code you've just written. It's inefficient, non-repeatable, and not always possible. For example, you have code that only runs on a certain day of the year. Console test rigs. When you create a console application to test your application, these are challenging to maintain and can be expensive to develop. Automated unit tests. Automated tests are great for regression tests, but are nowhere near as efficient as scripts for exploratory development.
Probably the one valid
Additionally, they require a great deal of experience to do correctly.
Valid.
I still use automated tests after the fact, but I have completely stopped any form of test-driven development since moving to F#. Section 2.7, where scripts and the REPL fit in. F# scripts are an extra tool in the development lifecycle through which we can change how we develop. Figure 2.4 illustrates some of the different scenarios.
Figure 2.4. The different types of uses for F# scripts.
As you can see, a great deal of development can be done in scripts, particularly in the exploratory phase of developing a project. By this, I mean anytime you want to create a new module or component in your application and want to start by sketching out a rough idea before formalizing it. Figure 2.4 represents my view of how you should use scripts and what a typical development cycle in F# might look like. You'll typically start in a script, trying things out. Once you're happy with the result, you'll port it into a full application, whether a console application, background service, web application, etc. Once done, you might do a quick end-to-end test just within the app to validate that things work in an integrated fashion. Perhaps you'll even automate that integration test. Finally, you may opt to write some regression tests to prove that the behavior of your code isn't accidentally changed in the future. In terms of creating new code or validating
It's the annoying part of software engineering. So you mean retest it? Why do we have to have a fucking term for every stage of the process? Okay. Okay. Thanks.
Figure 2.4 represents my view of how you should use scripts and what a typical development cycle in F# might look like. You'll typically start in a script, trying things out. Once you're happy with the result, you'll port it into a full application, whether a console application, background service, web application, etc. Once done, you might do a quick end-to-end test just within the app to validate that things work in an integrated fashion. Perhaps you'll even automate that integration test. Finally, you may opt to write some regression tests to prove that the behavior of your code isn't accidentally changed in the future. In terms of creating new code or validating that something is working in the first place, as far as I'm concerned, the idea of console test rigs and test-driven development is out for most use cases. Until now, you've been taking my word for all of this, so the rest of this book will prove it through practical examples. I want to give you one last piece of advice before going any further. To fully benefit from learning F# in the most effective manner, to quote Yoda, you must unlearn what you have learned. If you can resist the temptation to see F# as an alternative syntax for designing code in the way you do today, and trust that there's an alternative way to solve the same kinds of problems, you're halfway there. Summary. F# encourages you to focus on composable, declarative code that promotes the separation of data and behavior. F# changes the relationship between you and the compiler. F# is a part of the .NET platform, which runs on Mac, Linux, and Windows. You can write F# in Visual Studio Code with the Ionide extension. The REPL and FSI are key tools for learning and working with F#. Scripts are great ways to create snippets of code and can be reused for multiple purposes. Chapter 3, F# Syntax Basics. This chapter covers understanding core F# syntax, working with type inference in F#. Now that you've gained a basic understanding of F# tooling and have spent a little time writing some, admittedly simple, F#, it's time to learn about the core elements of the F# language. Many of the concepts and elements that you learn in this chapter are what I would call cross-cutting. They don't have specific effects in any one type of application or use case, but form the underpinnings of almost everything else in the language. So it's important to make sure you learn these concepts thoroughly. The first two, syntax and type inference, will give you an insight into the structure and look and feel of the language, while the second half of this chapter will help you understand how you'll be structuring and composing applications together and building basic routines at a fundamental level. Section 3.1, F# Syntax Basics. The core syntax rules of a language say a lot about the feeling of the language. For example, some languages may focus on being highly explicit and verbose. I would, for example, put Java into this category. Others may be terse and powerful, but require more investment up front to understand what's going on. Haskell, perhaps. Others might be lightweight with the intention of getting out of your way, but don't allow you to easily define the rules of what you're trying to achieve. Go and perhaps Python. Section 3.1.1, Characteristics of F# Syntax.
Shots fired, brother.
I would say that F#'s goal as a language from a syntactic point of view from day one has generally been to be highly succinct and highly safe. Most fans of dynamic languages complain that the syntax of statically typed languages is too verbose, which gets in the way of actually getting stuff done. And in some languages. I'd suggest Java as one. It's possibly true. The C# team has made a big effort to improve matters here, although I'm not entirely sold on the latest revisions of the language. Meanwhile, the C# Java folks, those coming from a static type system, point out that refactoring is difficult without a type checker and compiler, and potentially affects scaling a team without writing a large number of unit tests. F# hits a real sweet spot here. It's lightweight, readable, and type-safe all at the same time. Don't believe the myth that you can't have a programming language with all these three factors, because F# proves it's possible. I'd like to cover just a few points regarding these language characteristics, as it'll help you get into the right mindset when looking at F# code samples, and will probably bring into question some accepted fundamentals that you might be used to from other languages. I've heard people use the word terse to describe F# syntax. However, this is misleading. It causes people to fear that F# is full of arcane symbols, with the goal being some kind of code golf to reduce the number of characters used in a program. That's totally incorrect. Succinct is a far more appropriate term. It refers to F# stripping away of unnecessary symbols and keywords that other languages rely on, resulting in your code having a far greater percentage of text relating to business logic than syntax. Readability. F# code is generally very pleasing to the eye. Of course, I'll acknowledge that this is a somewhat subjective matter, but it's been my observation that compared to other languages I've worked in, it's far easier to write code in F# that is easy to understand. For example, F# has a relatively small number of symbols and characters needed for different features, far less than, say, modern C#. Many operators you might see in other languages don't exist in F#, instead replaced with human-readable functions. For example, instead of negation being exclamation mark at the start of an expression, F# has a function called not. The lightweight syntax helps, while F# also has some nice tricks up its sleeve to make it easy to create domain-specific languages, DSLs, and write code that can be read by non-technical people, which is very useful when you're trying to validate that your model aligns with the business purpose. Sensible defaults. F# has defaults optimized to the most common cases, meaning that we need to type less to get the same thing done as in many other languages. In effect, this means that your code will generally have a much higher amount of code that relates to the problem you're trying to solve rather than code that's there to satisfy the compiler. A good example of this is public versus private status. In many other languages, members are private by default, and you must explicitly mark members on classes as public, even though more often than not, members are public rather than private. F# flips this around, so public is the default. Don't be alarmed if you're coming from languages such as C# or Java. You'll see in upcoming chapters why it's perfectly safe in F#. Consistency. Where possible, F# uses a core set of language constructs and symbols that can be applied in many places. For example, Functions and simple values are declared using the same pattern and syntax.
See this code.
Notice both use the same let XX equal sign pattern. In this way, you can think of simple values as being the same as functions, except that they happen not to take in any parameters. This philosophy of consistency is replicated in many places in the language. There are very few one-off language keywords for specific features, but rather flexible and general-purpose ones that cover many different situations. For instance, the type keyword is used to define records, classes, interfaces, and unions instead of having multiple keywords for each. Another example is the async await pattern prevalent today in many other languages, which, interestingly, was originally modeled on F-sharp's async blocks. In F-sharp, async await is replaced with a general-purpose language feature that can be used in many different situations, not just for asynchronous code. A worked example. Listing 3.1 contains a typical F-sharp code snippet showing the definition of a function that takes in a number as input, adds 10 to it, and then doubles it. It then prints out a description of what it's done before returning the answer to the caller.
Listing 3.1.
It's pretty cool. So it reads like plain English. So let function argument, let add 10, then double, takes in one argument, which is the number. Open function scope, let added 10 equal the input plus 10. Let answer equal this function, so the output of the number plus 10 times 2. And then built-in function to print this statement with string interpolation, the number plus 10. Times 2 is, oh, so we're just replicating here. And then let website equal system universal resource identifier org. And then answer answer added 10, okay, times 2. And then there's an implicit return, so we just get the value back. Wow, brother. Okay, the block following is unfinished. The expression must have a result. Let cannot be the final code element in a block. Consider giving this block an explicit result. Thought I didn't have to do explicit. Or is this a program? No, it's Thought you didn't have to do that. Brother, come on, man. Answer. Control P. Is incomplete. Because the print FN statement is the last expression in the function and it does not return a value. F sharp, the last expression in a function, is the return value. Yeah, here. So what's going on? Returns unit, essentially a void type. The function is expected to return unit, but the function signature implies it should return an integer. Yeah, since answer is an int. Okay. To fix this, you should ensure that the last expression in the function is the value you want to return. In this case, you should return answer as the last expression. Thought I was. Okay, how's that different than let added 10 then double the number, let added 10 the number, let answer the number plus 10 times 2 is answer, yeah. I think that's kind of random. Maybe that's not supposed to be there at all. It doesn't seem like it should be. Maybe that's a errata in the book. Fucking A, dude. God damn it. What? Oh, did I do that? Okay. Oh, what did I do? Error occurs. Why? Still doesn't fucking run. That's annoying. Let's see what. I saw a bunch of comments here. Fucking sorry ass. What is wrong with this? Why did they put... I was wondering about that because I've been poking around other books and they were using this old school... these old school symbols too. What a weird mistake to make, though. D plus 2 is D, E. The number, that function times 2, and then return answer. I guess nobody knows how to write F sharp. Being cautious. I just want it to fucking work. I want to know which one worked. Oh my god. Am I missing something? Typical. Showing the definition. Can you just fucking be straightforward, dude? What in the fuck? Like, I think I'm supposed to omit that part. Samples, F sharp. Just doing simple fucking math. Here we go. Let, how about I really want to know why that doesn't work. Seems like it should work. Claude would know. Takes a parameter, the number, yeah, adds 10 to it. Yes. Doubles the result. Inside a formatted string showing the calculation. Creates a URI object pointing to the F sharp website and then returns the calculated answer. Yeah. guess, but oh, it says a program, it's successful, no warnings. Oh, as an expression, I guess you have to then call it? Answer? It's not? But it should just... Oh, answer. Wait. Answer. Now everything looks wrong. No parentheses, no... The final line answer makes this valid. It serves the result expression for the function block. However, if the code ended with the URI creation, this just seems so random. But it should work without that. Bah, but it doesn't. Yeah. But why? Oh, the number answer. That's okay. So I need the number answer. Still no. F-sharp compiler applies different rules when evaluating expressions in interactive mode or when defining functions that return values. It treats the incomplete. Okay. Correctly as an expression. Do I have to do that here? Maybe that's why. Of course you don't fucking say it. Fucking. Maybe it's my fault for using this little buttfuck tool. Alright, how about this? Where's the terminal? Nothing will happen when it's run because I'm not calling it. Effing answer. How about that? Oh, I can just run it here, eh? Yes. Will that work? Ooh, alright, hold on. Maybe. What about that, bitch? FSX. Hmm. Doom, 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 doom. I must have missed something. Typical F# code snippet showing the definition of a function that takes in a number as input, adds into it, and double. I don't know. Just don't know. Fucking lame as fuck, dude. It's like a $40 book. First fucking snippet. What pisses me off, it doesn't show the output. Normally, they'll show in the comments what the output should be, at least proving whoever wrote it fucking tested it. Stop fucking showing me C#. Now I'm triggered. Alright, the let keyword. Let's move on and look at... Yeah, let's fucking move on.
Let's move on and look at the let keyword. This is the most important keyword you'll use in F#. It allows you to bind values to symbols. We can illustrate its use in this arbitrary example.